gotta check if this is working first. Okay, so sweet, this is working. I actually did a ton of questions, but something bugged out in part 3, so I don't know where I ended off at, but I finished linked list, I finished trees. I think it was somewhere like trees. I quit working, but I finished the rest of trees. Yeah, sorry you guys didn't get to see that. Let's see, last submitted. But you can believe me, like the last video I was just talking into space. So it'd be kind of dumb for me not to record it, but yeah, these are all of these problems. These ones are actually kind of hard. We're not gonna do sorting and searching. I give a huge explanation on memoization and how dynamic programming works. But I'm not gonna do that again. That's too much work. So we're just gonna finish the rest of these questions. I think I already did this one by accident. Yeah, this isn't even like dynamic programming. At least I don't consider it dynamic programming. You're not saving any values for future calculations. You're just carrying over values. So I swear we did this by accident. Yeah, dude, Leetcode is clean. Oh, okay, I haven't submitted any code. You want to maximize choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Okay, we haven't done it then. Have not done it. A single day. So we could buy on 1, sell on 5, and then sell on 6. So 1 and 6. So 1 and 5. I think we can. So we see 7. We're like, okay, no buy. We see 1. We're like, buy. Actually, we see 7. We see buy. We see 1. We see buy. We see 5. We see sell. Profit is equal to 4. Profit is equal to 4. We see 3. We see buy. We see 6. We see sell again, but this time we could have a profit equal to 3 or profit equal to so should we just store the minimum value before? So like, see, in the 6 we want to find the minimum value before it, right? So what if we just store like the minimum value each time we do it? So min is equal to 1. Over here, the min is equal to 1 again. Over here, the min is equal to 1. But the profit you can get is equal to 3. The min is still 1. But the profit you can get is still equal to 4. And over here, the min is still 1. The profit you can get is still equal to, is now equal to 6. So I guess that's what we memorize or save for future values. We just store the minimum value we see. Okay. Int min. Because the buy day have to be before the sell day. For int, I is equal to 1, I is less than prices dot length, I plus plus. If prices min buy is equal to math.min of min buy and prices at I, profit math.max of prices of I minus min buy and whatever the profit currently is. We can just return profit at the end. Okay, I think that's pretty easy. So just think about it. As soon as we see 6, we don't care which day we buy it. We just want the minimum day. Ooh, I think I understand it now. Yeah, like what the hell is this code? This code is unreadable. I mean, you can read it. Let's see what they're doing. Lowest found price, update lowest found price, price is, so optimal price, return optimal price. See, I can read this garbage. I can read it. But I can also acknowledge that, yo, it's garbage. Like, realistically, you read this code? Price is, so you read this code, you're like, oh my god, bro, does this guy really think lowest, smallest value, optimal price, price ist, price current instance? Like, what the hell are you writing, bro? Learn how to write some variable names. Look at my code. Min, buy, and profit. That's all you need. That's all you need. Oh my god, man. I hate people on Leetcode that are like trying to like lower their runtime by like using smaller variable names. Like, are you I'm not gonna say it. Like, it's like some trophy to get like, oh, I got faster than everyone else. Bro, you're using Java. If you're using Java, you're slower than everybody. Use C++, not the Python people, but use C++ or C if you care about speed that much. Subarray with the largest sum. Okay, so every time you see any value. Oh, yeah, okay. I think I know how to do this. So the problem is we have negative values, because if it was non-negative values, then of course you just take every single value. But I think for this one, we just need to know when to toss the subarray, because it's not subsequent. Subsequent is just picking all the positive values. It's a subarray. So we see -2 and our next, which has a sum of -2, and our next value is 1. So make sense to join it? So we either have a choice. We have join or leave. Does it make sense for 1 to join or start alone? That's better. Start alone. Obviously, it makes sense for 1 to start a new one and start alone, because -2 plus 1 is -1. So we just have to make this decision at every index. Do we join or do we start alone? So if you had something like 10, -2, -3, -4, and your subarray was right now, it was 10, -2, 10, -2, -3, because you're like, oh, it makes sense to join the 10. Why? Because if you're -2 by yourself, you're -2, but with the 10, you're 8. And when the 3 joins, hey, I could be -3 or I could be 5. So this is the decision you need to make. Okay, and also apologies for part 3. I'm literally like, the audio cut off, the screen cut off. I think I've been running OBS for too long, so I had to like shut everything down, reset the mic. Max subarray. Int max subarray. Max is equal to 0. It's equal to, just say nums at 0. Cur is equal to nums at 0 as well. For int I is equal to 1, I is less than nums dot length I plus plus. So the cur is equal to math.max. Either you stay, so that's cur plus nums at I, or you leave. Pick, join, or leave based on what yields the most. Okay, and then every time you just update your max. This is keep track of the maximum subarray sum found. Return max. Oh my god, I'm cracked, bro. I'm cracked. I'm that. Can't say it, but I'm that guy, bro. I'm that guy. I'm cracked. Easy, easy. Yo, man. People complain about Leetcode. I'm going to do like 50 questions tonight. Don't do that, though. This is just what I do. Like, because I like to get out of the way. Honestly, I don't even do this normally. It's just that I'm doing a stream and I said I would. And I don't like going back on my word, bro. If I said I'm gonna do it, I'm gonna do it. Type of guy I am. I wonder if anyone's watching. It's kind of late. I don't think anyone would be. Honestly, I don't even do this normally. It's just that I'm doing a stream and I said I would. I don't like going back on my word, bro. All right, nobody's watching. House robber. Adjacent houses. You can't rob adjacent houses. Okay. So what do you want to do? Rule number 1. Maybe we should do this for all problems. We list out rules. No robbing adjacent houses. Rule number 2. Maximize profit. Okay, so let's think about this. We have houses A, B, C, D, E. So if we rob house A, you can't rob house B. You can't rob house B, but you can rob house C. But you can't rob house D. No D. If we work backwards, because we're going to end up at house E, right? That's where we end up. That's the last house. So in house E, we're either robbing or leaving, right? So if we rob E, then the profit is, what? Profit is equal to max of robbing E plus whatever function we have to rob C, which is E minus 2. Why? Because we can't do D. Can't do D. But the maximum profit is whatever we call from robbing E. So we gotta define a function, bro. Function. Let's call it like function func E returns the max profit from robbing house E. What is func E defined as? Func E is equal to robbing E plus the func of E minus 2, which is equal to C. So either you rob E and you want to take the max of these two values. So max, because you have a choice. Either you rob E or you don't. Func of E minus 1, which is equal to D. So it's like a recursive function where we try and calculate the max profit is equal to robbing E plus the next house. So we call the function on the next available house we can rob, which is C. Or maybe just robbing D is the best option. Now let's do a bottom-up approach. We could do top-down, but I don't like the recursive nature of it. Bottom-up is always my favorite. Inter-A. Yeah, my brain is fried. Like, oh my gosh, too much coding. For int I, 0, I is less than. Okay. Base cases. Let's talk base cases. The profit, so func at 0, the max profit, we could just call it profit, at 0 is equal to, well, robbing 0. And our second base case is, that's number 1. Number 2 is profit is 0. Profit at house 1 is equal to robbing house 0. But we want to get the max of robbing house 0 or robbing house 1. Because you can't do both because they're adjacent. What does this look like? So profit at 0 is equal to nums at 0. Profit at 1 is equal to math.max profit at 1. For int I is equal to 2, I is less than nums.length, I plus plus. Profit at I is equal to max.max of taking this house, so nums at I, and the max profit you can get from the next available house, so profit at I minus 2, plus, or profit at I minus 1. With this simple function, we can optimize whether we want to rob the house or not. That's the decision. What is our decision? Rob the house or not? That is our decision that we have to make at each step. And how do we make the step? We choose whatever maximizes profit. Oh my god, bro, I'm so tired. So tired. And then in the last house, that's the one we want to return. Why? Because after we rob the last house, we would have our maximum profit. Like, you're never losing money from robbing a house. Trust me. But easy. Oh, index 1 out of range. So if nums.length double equal to 1, return nums at 0. Always cover the base cases in your edge cases. Expected to. Oh, dude, this is nums at 0, not profit at 0. My bad. These are our base cases. There we go. Easy. Easy. Be 100%, bro. Easy. And I explained it too. Lucky you guys. Math, phys buzz. I'm not gonna do design because like a lot of design is like it's kind of like annoying. Yeah, I'm not gonna do that. This one, let's see. Randomly shuffle the array, so I'm gonna have to like read the random library for Java. Should be equally likely. That just means use a random library. Yeah, so you just have two arrays, one that has the original values and one that you shuffle. And then whenever you press reset, set the shuffle one to the original. That's it. Let's see min stack. I'm gonna tell you how to do it. I'm not gonna code this up. Minimum element and constant time. Bro, this is definitely not an easy problem. Top is a top element stack and min. Okay, dude, how would you do this? Maybe you would. I don't know actually. Min stack. Let's think. Okay, let's think. For each function? Damn. This is actually a great question. Because like I feel like this one where you had to work with your interviewer, because it's actually kind of hard. Because all of these are easy. Get min is hard. How do you get min? Do you maybe push it onto a priority queue? Maybe. Not sure. Do you... Yeah, I'm not sure about this one. I don't got all the answers, okay? I don't got all the answers. This one's kind of hard. I gotta think about that one. But I'm not gonna look at the answer right away. You should think about these problems a little bit. This is a dumb problem. People think like if they see you code this, they think, oh, you didn't do optimal if statements. Haha. I know you're a terrible engineer now. And I'm like, bro, what are you talking about? Because if you're a good engineer, you use string builder. Why? Because you know that strings are immutable. And then declaring a string means that you're reallocating all the space for it. But I don't care, so I'm going to use string. How does FizzBuzz work again? Is divisible by 3. So if I mod 3 output see, the trick is you want to use only 2 if statements instead of 3, and then somebody will be like, oh my god, you only use 2 if statements? This guy's crazy. And the third condition is output is equal to empty, then plus equals I dot to string integer dot to string integer dot to string I output dot add I or out. Alright, I think this is like pretty dumb problems now. I don't want to do them. Expected 1, 2, FizzBuzz. I got FizzBuzz 1, 2, so you guys are 1. Yeah, the math problems are kind of lame. Like Roman to integer. I think I remember this one. It's just a whole bunch of if case, out case, edge case. So being able to find some good conditional flow logic here. Power of 3. Let's just look at it. If it's a power of 3, dude, just mod 3 until it's 0 or not 0. I'll do this question. While n is greater than or equal to 3, n mod equals 3. Actually, no, it wouldn't work. N divided by equals 3. No. So if it's not divisible by 3, so if n mod 3 is not equal to 0, return n is greater than 0. So return false, and n divided equals 3. And then you could just return true. So if it's 27, it'll be 27930. 93 greater than equal to 1. Return n is equal to 1. 0 is divided by 3, right? What? False. Man, what the heck? So, what am I doing wrong? So first one, 27 mod 3 is 0. So 27 mod 3. 27 mod 3. Actually, 27 mod 3 is 0, yeah, because 9. Greater than or equal to 3. Yeah, if n is equal to 3. Does that work? Oh yeah, and of course, if n is double equal to 1, return true. So you see what I did here? I erased the issue with the 3 because it goes 27, 9, 3, and then 1. So I just stop when it's equal to 3 and then break out of that loop. And I have an if case for 1 because 3 to the power of 0 is 1. Oh yeah, so easy. Count primes. There's no good way to count primes. This question probably is number of prime numbers that are strictly less than n. This number is probably like, well, first off, you can skip like, how do you define a prime number? Number only factors are 1 and itself. First off, skip all odd numbers or all even numbers. After 2, of course. Afterwards, you just need to check with other primes. Why? Because think about something like 30, 40, right? It breaks down to 4, but that also breaks down to 2. What about like, let's think of a hard one, 21. That breaks down to 7 and 3. Those both are prime. But eventually something will break down to a prime. So everything, eventually, it all breaks down to primes. So what you want to do is compare against your current list of primes with modulus to check if it's a prime. So, we know, is 1 prime? I don't know. For int I is equal to 1, list of integers, primes equal to new array list. Primes I'll add 2, 3, I is less than equal to n, I plus plus, 4. Int is actually boolean is prime, so we always assume is true. For int a in primes, if I mod a is double equal to 0, is prime is equal to false, and we should break. If is prime, then we could do primes dot add I. Let me make sure you guys can see that. If is prime, primes dot add I. Oh my god, no more water either. Okay. If is prime, primes dot add I. In the end, return primes dot size. Just that. Yeah. So again, everything breaks down to primes eventually. 0, output 1, expected 0. If n is less than 2, turn 0. Everything breaks down to primes. Two is not a prime? What are you talking about? Strictly less than n. Okay, maybe I'm not doing this right. Oh, okay. Okay, yeah. I don't know, man. I don't know. This one's actually a good question. I thought this would work pretty well. Okay. Dude, you know, sometimes with these problems, if I'm really tired like I am now, I will cheat. I would cheat. And these math problems, especially, it's usually just some like fancy trick. There's not usually like, it's usually like a mathy solution. Intuition. Wow, this guy tells us nothing. Assume all numbers are prime. Deceive a Euro-Tannies. Yeah, I don't think I'm gonna derive that, bucko. Deceive of a Euro-Tannies. See, this is garbage I'm talking about. No interviewer is gonna ask you. Be like, oh my god, you didn't know what deceive era what Tanasis was? 10 million or so. Come on. Everyone should know that sieve of erotonesis, erotosynthesis, erotosynthesis. This is pretty cool though. Yeah, it's actually kind of cool though. I feel like it's like those cool math stuffs you can learn. Oh, this is actually this is a great way. I see what they did. This is classy. Oh, this is very nice actually. Yeah, actually I can see how anybody could get this. This is a very classic solution. So the way they do it is every time you find a prime, just negate all multiples of those primes and be like, hey, that one's not valid. Don't even look at it. It was kind of what I was doing, but it's kind of theirs is better because they negate it right away. For me, I have to check through all the primes and be like, oh, again, this 3, it's a 40, it's a 39. This 3 should cancel it out. So theirs is like a cleaner, way more optimized version of whatever I wrote. But I think this is it. You know, I'm tired. How much did we get to? We got 37 problems solved today. It doesn't sound like a lot, but yo, man, I'm so tired. I think that's a win for one day. Oh, dude, did we go into day 2? Oh, dude, screw that. Okay, well, I'm going to do all the medium questions tomorrow. I think this is all the easy ones done. All the ones that matter, which are dynamic programming, trees, linked lists, strings, and arrays. Yeah, look at those green things lined up. Sorting and searching really doesn't matter. Design matters. I should learn how to do this problem. This is on my to-do list now. Let me write this down. I'm going to spend some time tomorrow just sitting down thinking of how they actually did this solution. I don't know, or not the solution. How I would solve this problem. Math is kind of useless. It's kind of cool though. This is only if you're like super low level. Bits, having distance, bits, all that stuff. Okay, send the stream. Goodbye. 37 questions on today. I'm so tired. Bye bye.